Hi everyone. So now in this video we are going to be covering Kruskal's algorithm. So in the previous video we had covered Prim's algorithm, which is a greedy algorithm used to solve minimum spanning trees. And now Kruskal is another greedy algorithm that has the same function, which is to form the minimum spanning tree. Okay, so the steps for solving Kruskal are as follows. The first step is to sort all the edges by weight. The second step is to initialize each vertex. Initialize each vertex as its own set. The third step over here is to pick the smallest edge. And then add it to the MST. And you will repeat the process until we have v minus 1 edges. So that means in prims we go point wise, that is vertex wise, but in Kruskal's we go edge wise. Okay, so now let's do a question to understand this topic better. So the question is as follows. We have the same graph that we did for prims. Okay, so A to B, then A to C, then B to C, then B to D, then C to D, and then C to E, and then D to E. And the edge length are also same. Why we are keeping it same? We are keeping it same so that when we are solving it, the answer which we get should come the same. So if the answer that we get comes the same, that means we have done it successfully with the help of both Kruskal's and Prims. So now the question states, find MST using Kruskal's algorithm. Using Kruskal's algorithm. Okay, so find the MST using Kruskal's algorithm. So now let's take all the edges and sort it in ascending order, which is our step 1 of this question. Sort edges in ascending order. Sort the edges in the ascending order. So how do we sort it? So let's take every edge one by one. Okay, so when we sort in ascending order, first we get BC, which is 1, then we get BD, which is again 1, then we get AB, which is 2, then AC, which is 3, then CD, which is 4, then CE, which is 5, and DE, which is 7. So these are the edges in ascending order. Okay. Now step 2 of Kruskal's algorithm is to take edge by edge and then pick them one by one. Check if there is no cycle formed. If there is no cycle formed, then we add that edge into MST. Let's see how that works. So check every edge. So first we'll check BC. There's no cycle, so we'll add it. So MST will become BC. Then we'll take the next edge, which is BD. This also doesn't form any cycle. So the MST will become BC, comma BD. Thereafter that we'll take AB. Here also no cycle is formed. So our MST will become BC, BD and AB. Now we'll take AC. If you take AC, then ABC will form a cycle. So that's why cycle is formed, so we skip it. Then we take CD. Again, BCD will form a this thing. BCD will form a cycle. So we'll skip this again. And then CE will pick. Here there's no cycle formed. So we add it into the MST. So our MST is BC, BD, AB, and then CE. And now as the number of vertices are, no, number of edges is V minus 1, that is 5 minus 1. So we stop. So what is the MST? The final MST is BC, BD, AB, and CE. Let's take the graph and we'll draw the MST. And let's take the total weight before that. 1 plus 1 plus 2 plus 5, which is 9. Now let's draw the graph. So we get A to B to C to D to E. So what all are there? BC, BD, AB, and CE. So these are our 4 edges which make the minimum spanning tree. Okay, so this is the minimum spanning tree using Kruskal's algorithm.